or gold is yellow. Ca is a metal, whereas Cl is non-metal. The valency gradually rises from 1 to 4 and then falls from 1 to 0. No, 1, 1 to 4 falls from 3 to 0. The elements in a column have the same valence. Li, Na, K as well as F, Cl, B, Mg, Ca, Bal, Li, H, Li, Na, K. He inert gases. Group number 80. The elements He, Ae, Ne, Ar do not combine with other elements and are therefore assigned the valency 0. They are also called noble gas elements. Monoatomic HeNeAr, H2N2, O2, F2Cl2, O3PA4H8. Excess of electron minus d by 1. Excess plus KNO3, potassium nitrate, NaHCO3, NH4NO3, ammonium nitrate, Na plus CO2 Na2CO3, sodium carbonate, NH4 2 SO4, Cl SO4, Fe SO4, Fe2 SO4, iron 3 sulfate, Al3 whole 2 SO4 whole, Al2 SO4 whole 3, and aluminum sulfate, AFBY, Na2Y, CaCl2, CaCl2 minus plus 2 plus Al2O3, Al2O3, ALN, aluminum nitrate, 3 plus 3 minus 3. reaction H2O2, hydrogen peroxide, C2H2, acetylene and C4H10 in which the numeral subscripts are not divided by a common factor. Some elements show variable valence. Cu 23 A12 23 C342 246 sulfur 246. A radical is a kind of entity that can be an atom with a charge on the group or a group of atoms with a charge on the group. We know that matter is made up of tiny particles called molecules, and that molecules are held together by a force of attraction called intermolecular force. There is also a space between the particles called intermolecular space. The force of attraction and also the space between the particles differ from substance to substance, but for any substance, the stronger the intermolecular force, the smaller is the intermolecular space, and smaller the intermolecular force, the larger is the intermolecular space. Weaker. There you go. Intermolecular force is the strongest in the solid state, weaker in the liquid and weakest in the gaseous state. And the intermolecular space is the smallest in the solid state, larger in the liquid and largest in the gaseous state. The constant, this is for interconversion of states of matter. The constant temperature at which a solid turns into corresponding liquid is called melting point of the solid. The constant temperature at which liquid freezes is called the corresponding is called freezing point of the liquid. Ordinarily, The freezing point of a liquid is the same as the melting point of the corresponding solid. Water freezes as well as ice melts. Let's theoretically consider. The constant temperature at which the liquid boils is called the boiling point of the liquid. For example, the boiling of water is 100 degrees centigrade is the temperature which in the final. All matter is made up of tiny particles called molecules. In the solid state, the particles are rigidly held in position above which one only vibrate. In the liquid state, the particles are in continuous random motion or not separated from each other. While in motion, they collide among themselves. In the gaseous state, the particles are in continuous random motion almost independent of each other. The particles in a gas travel much longer distance before they collide with other particles in orbits fall out the vessel. The particles in a gas travel much longer distance than in the liquid before they collide with other particles in the wall of the vessel. The collision of the particles with wall of the vessels gives rise to the pressure of the gas. The particles possess some energy due to their motion. This energy is called kinetic energy. The kinetic possessed by the particles is dependent of temperature. Higher the temperature, higher is the K. Lower the temperature, lower is the K. The particle considered a solid only vibrate over their mean position. As the solid is heated, the kinetic of the particles increases. With rising temperature, particles vibrate more and more vigorously till they move away from the fixed position. At a particular temperature called melting point of the solid, as the solid becomes a liquid. Liquids to solid. As the liquid is cooled, the kinetic of the particle decreases. The particles move shorter and shorter distances as the temperature is lower. At the freezing point, the translated motion from one to another point ceases. The particles get rigidly fixed. This is how a liquid changes into a solid. However, the particles in the solid continue to operate in mean position. The particles in a liquid are in continuous random motion during which they collide among themselves. They collide strongly. Some of the particles will overcome the attractive force and escape. A liquid evaporates in this manner. Matter can neither be created nor be destroyed, but can be changed from one to another, and the total mass of a substance before and after the change remains the same. This is known as the law of conservation of mass. Structure of an atom. Dalton's theory. Elements are made of a very small particle called matter or atom. Atoms are indivisible. Atoms of an element have the same weight. Atoms of different elements have different weight. It is the atom of an element that takes part in a chemical reaction. The atoms of an element combine in simple numerical ratio with those of elements to form a compound. An atom is defined as the smallest part of an element that takes part in a chemical reaction. Minus 1 is plus unit 0, 1 by 1 is 0 automatic, 1 by 1. A proton is 1840 heavier than an electron. Mass. Unit of atomic mass, unified mass. The same mass is proton, but no electrical charge on it. James Chadwick and proton Goldstein and electron is J.J. Thomson. atomic number or the proton number of an element is the number of protons present in the nucleus of the element. The sum of the uh, proton number and electron number is known as the mass of the atom. One 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 0 2 4 3 7 4 9 5 11 6 12 7 14 8 16 9 19 10 20 11 23 12 24 13 27 14 28 15 31 16 32 32 17 35 18 40 19 39 20 40 1 1 2 4 3 7 4 4 9 5 11 6 12 7 4 7 14 8 16 9 9 19 10 20 20 10 20 11 23 12 24 13 26 27 24 27 28 31 32 35 40 39 40. An atom is the number of subatomic particles or electron, proton, neutron. Electron, negatively charged particle, were discovered by cathode rays and discharge of tube by J.J. Thomson. For J.J. Thomson, the Goldstein. The positively charged particle were discovered from the anode in the discharge of the tube containing hydrogen. Proton was discovered by Goldstein. Neutron, the electrically neutral particle, were discovered by action of a particle on the element